Welcome to the team. Seriously, I am absolutely thrilled to have you on board. As a senior Microsoft Azure SQL database expert, part of my job is to make sure you are completely primed and ready to go for your upcoming DP-300 hands-on lab. Today, we're going to walk through exactly how to diagnose and cure database fragmentation. Think of this explainer as your ultimate step-by-step blueprint. I want you to really grasp the theory, the code, and the whole methodology before you even touch a keyboard. Okay, let's dive right into this. So picture this. We've got a pretty high-stakes clinical scenario in front of us. In your lab, you are stepping into the role of a newly hired database administrator for AdventureWorks. Now, this is a massive company that's been selling bicycles and parts globally for over a decade. But right now, they're in crisis mode. Recently, they've been suffering from this sudden, severe performance degradation whenever customers make requests. Operations are just grinding to a halt, and it is entirely on us to fix it. We need to identify the disease and, more importantly, administer the cure.
Here is the exact diagnostic blueprint we'll be following today. 1. The AdventureWorks performance problem. 2. Causes of index fragmentation. 3. Diagnosing the database. 4. Rebuilding for peak performance. And finally, number 5, validating the solution.
All right, kicking things off with Section 1, the AdventureWorks performance problem.
You know, every good DBA starts by closely examining the symptoms. Down at AdventureWorks, the glaringly obvious symptom is painfully slow customer requests. But as data professionals, we look a lot deeper than that. Behind those slow requests, we're actually seeing an incredibly high number of what we call logical reads. A logical read simply happens when the database engine has to fetch a page of data from the data cache just to satisfy a query. When that number suddenly spikes, it means your database engine is working entirely too hard to find the data it needs. It's basically scanning way more pages than it should ever have to.
Moving right along to Section 2, causes of index fragmentation.
So what actually causes a database to suddenly require so many logical reads? Well, the answer is index fragmentation. The primary culprits here are frequent updates, heavy inserts or deletes, and page splits. Let me give you an analogy because it really helps visualize this. Imagine your database index is a beautifully organized, massive encyclopedia. But over time, people come in and literally rip pages out, scribble in new entries, and then aggressively shove them back into the entirely wrong places. The pages are completely out of order now, and the index is physically fragmented on the disk. So when a reader, or in our case, a database query, needs to find information, they can't just flip straight to it. They have to search much harder, reading through tons of disorganized pages. That right there is a page split, and that is fragmentation. Now, in your upcoming DP-300 lab, you aren't just going to passively look for this disease. Oh no, you are going to intentionally inflict it. You're going to execute a T-SQL script that absolutely hammers the person.address table with 60,000 inserts, then 25,000 deletes, and then another 40,000 inserts. By causing this massive, chaotic data churn, you will force those page splits and watch the database become highly fragmented in real time. Honestly, it's the absolute best way to truly understand the problem.
Okay, Section 3, diagnosing the database.
Listen, as an Azure SQL expert, I never guess, I query the dynamic management views. Here is the exact 3-step diagnostic code you're going to use in your lab. First, you'll query the system function sys.dmd_db_index physical stats. This basically asks the engine to give you a health report on the physical database pages. Second, you join that with sys.indexes just to get the readable names of the indexes. And third, and this is absolutely crucial, you filter for average fragmentation in % greater than 50. We are specifically hunting for indexes that are more than 50% completely out of order. And this brings us to the shocking aha moment you're going to experience in the lab. When you run that diagnostic query after all that data churn, you're going to find 4 highly fragmented indexes. But the biggest culprit of them all, the IX_address_state province ID index. It's going to come back suffering from a massive 88% fragmentation. Essentially, 88% of that index's pages are just completely out of order. No wonder the logical reads were going through the roof.
Which naturally takes us to Section 4, rebuilding for peak performance. We've got a definitive, severe diagnosis, so now we need the treatment plan. Say hello to your new best friend, the alter index rebuild command. Look, when an index is this far gone, we're talking over 50% fragmented, simply reorganizing it just isn't going to cut it. We need to completely rebuild this thing from scratch. This command drops the messy, disorganized index and creates a brand new, perfectly contiguous one. It's literally like throwing out that torn up, messy encyclopedia and just buying a brand new, perfectly printed edition.
In the lab, your syntax is going to look exactly like this. You're going to target the specific broken index, ix_address_state province ID, on the person.address table, and you will instruct SQL to rebuild it. That partition equals all option simply means we are rebuilding the entire index across all partitions. Once you hit execute on this, the database engine goes straight to work, restoring perfect order.
And finally, Section 5, validating the solution.
Now listen closely, because this step right here, this is what separates the amateurs from the professionals. A senior DBA's job is never ever done just because the script ran successfully. You must validate the recovery and prove that your cure was actually effective. Look at the dramatic shift you're going to see in your lab. Before the rebuild, we had a severely sick database sitting at 88% fragmentation. But when you rerun your diagnostic query after the treatment, that fragmentation drops to a beautiful, perfect 0%. The index is absolutely flawless.
But how do we actually prove that this fixes the customer experience? Well, before you run your final test query to count the customers per state, you're going to execute set statistics IO time on. This tells SQL Server Management Studio to track exactly how hard the engine is working behind the scenes. When you pop over to the Messages tab in SSMS, you'll see undeniable proof. The number of logical reads will have completely plummeted. Because the index is perfectly ordered now, the database engine can find the data almost instantly, completely curing the AdventureWorks performance degradation.
So let's recap. We identified the symptom, diagnosed the heavy fragmentation, rebuilt the index from scratch, and fully validated our massive performance gains. You now hold the complete blueprint. But I want to leave you with a thought. Ask yourself this. As your databases scale to terabytes, and these exact same page splits happen literally millions of times a day, how will you automate this cure to keep your systems running flawlessly while you sleep? Keep that in the back of your mind as you jump into the DP-300 lab and rebuild these indexes yourself. Go crush it.
This section of lab, we'll go through DP-300 database administrator, and lab number is 7, detect and correct fragmentation issues. If you are new into this channel, please subscribe to my channel, and you can go through other videos that lab videos I focused. I have also added an overview before going through the labs. And I'll also pass this GitHub link into description section so that you can follow when you do into your lab environment. So if you go through this lab, so here that you have been hired as a database administrator to identify performance related issues and provide viable solution to resolve any issues. So and this section is focusing on the fragmentation issues. So let me start the lab and go through that one. So for this lab perspective, other thing that you need to download it the required files. Yeah, so for that you will go to this GitHub link and you can download those files and make sure all the resources that relate to this lab, like correct resource group and the server, SQL Server and SQL databases are configured. So here labs, click the labs button options and then open in a terminal window. Let me zoom in. So let's connect to the Azure portal. And log in using your ID password. So we do not need to log into portal for this one. So let's connect to the management studio. So when that open, connect to the server, select all the like server type default values, which is then and then click on connect button. Or before that, you can select the trust server certificate and then select connect. But when you do your own environment, you need to create this server and you can connect to the right database server or SQL Server instance. And then select this database folder and right click and you can select new query options. I cannot see that on here, so just select that button, then click here new query. And when you that window open, query window open, copy and paste the query from the lab section. Let me type then. So what it is doing, it's just restoring that database name is this one, and it's getting that backup. And then the recovery options is getting that move this from there. You can see that this is the data file, DF, and this is the log file. Log file will go there. So this is the data file location. This will be log file locations. Now click execute button. And you can see that it's running and upgrading. Now, if you go to that location, you will see that two files are created. If I go to C lab files, and you can see that one like data files for DF, and another one is for log files, which is transaction log files. If you click that, you can see that information type. So I'll be back when this restore complete. So restore completed. When restore complete, you can see or you should see a message indicating that and that completion here, that database restored and query executed successfully. Now let's do investigate index fragmentation. So open a new query window and copy the code. So this query will actually give a report based on which indexes are or have a fragmentation over 50%. So let's execute this one. So it's giving me, okay, it's a typo. Let me fix that one. So if I execute that again, oh no, there is another issue. Mm, should be fine now. So in our case, because we don't have anything, it's a new database, so we don't see any output for this query. So fragmentation can be caused by a number of factors like frequent update to the table or index, frequent insert or deletes to the tables or indexes, that also relate to purge splits also. To increase the fragmentation level of the table, that called person, let's go there. You see the database level, go to this database and go to the tables, and you can see that there are different tables related to the person. So let's go this person and address. So what we'll do to increase the fragmentation level, we'll insert and delete a large number of records. For that, let's do a query on that one. So click that new query and copy paste the code from the labs manual. So here I pasted the SQL commands. So here you can see that, or T-SQL code. So what we are doing, we are inserting 60,000 rockets into that address table, and then you can see after that deleting, again inserting to create fragmentation. So let me execute that one. Execute button. You can see that query is executing. So query executed successfully. Let me execute again. Query completed with error. This statement has been terminated because it has got duplicate rows, so that for terminated. So now let me execute the first query. Uh, Now we can see there are 4 tables, and it's giving like a highly fragmented index that we can see that index type. Now select a new query. For that, let's go to new window and type the command. So you can see that information here. The result pane for the SQL Server Management Studio. Query executed successfully, and you can see that results. Next, we'll rebuild fragmented indexes. So for that, let me open a new query window and paste the SQL. Execute the query. Command completed successfully. Now do a new query. So here actually we are going to check for a index. That index does not no longer has the fragmentation, which is greater than 50%. So we can see that fragmentation dropped to 0%. Next, we'll execute the statement from the previous section where we executed. Let me find this one to execute. This is very quick because it's not taking time, because logical reads should reduce here. So if we select that message button, we'll get that more information in here. You can see that this can count raw logical reads, physical reads, all those information you can get that from here. Just to make sure that logical reads, or it was better to execute defined window so that I could compare. Anyway, by going through this, you can get that informations. So we have completed our lab. It's always a recommended or good practice to reduce that uh, when you do into Microsoft Azure portal, create all the resources. It always be recommended practice to reduce or the services you do not need, or drop the resource group so that it does not incur any additional cost. If you have any questions, add that into comment section. Otherwise, see you into next lab.